This is the second video in our discussion of the fields that you get from a point charge that is moving with a uniform motion. And as a recap of the previous video, we solved for the electric field that you would get, which is pretty much looks like a Coulomb electric field, except for there is these modifications due to special relativity. Next, we want to look at the electric fields. I think we're going to start with an analogy where we start with the case of the parallel plate, uh, where we put a positive charge on the bottom and a negative charge on top. And the electric field would be in the y direction, so that's the blue. And this time what we're going to do is we're going to insert a surface current where the surface current K on the plus and minus plates is going to be plus and minus the charge area density times the velocity times x. Okay, so what is that velocity? That velocity is if the plates are now moving with a velocity v0 in the x direction. So we're getting a current because we are getting the charges essentially moving as the plates move. So the charges are not migrating around on the plates. We get a current because the plates are moving with a velocity inside the frame. Okay, so if that's true, then I've drawn here what you would get for a magnetic field would be in the z direction because of the right-hand rule. So the magnetic field that we would expect to measure in the z direction is minus mu 0 times the current, essentially. Okay, now let's say that we have a third frame which is now moving with the velocity v. So this is what we have is the parallel plate capacitors in their rest frame S0, and now the capacitors are now moving in a frame S with a velocity v0 with respect to their rest frame S0. And now a third person is going to come along and make a measurement, and that person is the S bar system, which is moving with its own velocity v with respect to the S frame. So the velocity v is with respect to it's S bar with respect to S. So v is measured against S, and v0 is the S with respect to the capacitor's rest frame S0. So we're kind of stacking them up as we go. Okay, so that means the relativistic, the measurement of the velocity of, which I would call v bar, with respect to S0 I already have a t in there, with respect to S0 would be v plus v0 over 1 plus v0 over c squared. Okay, so now S bar can make statements about how it's measuring the fields based on the rest frame of the capacitors. Okay, the gamma, again, with respect to S0 would be 1 minus V bar, like so. Okay, so that means we can now say S bar can say make a measurement of the charge density based on the rest charge density, and that would be gamma bar sigma 0, which is gamma bar sigma, which is the charge density in the S frame, divided by gamma 0. Okay. So now let's start applying that to fields. If we look at the measurement of the electric field in S bar with respect to the rest frame, then that would give me gamma bar over gamma 0 sigma over epsilon naught. The magnetic field measured by S bar with respect to the rest frame is minus gamma bar over gamma 0 mu 0 sigma V bar. Okay, so since we have a gamma bar over gamma 0, let's work that out. And what we get is square root minus V0 squared over C squared. That's the gamma 0. Something like that, which is that whole thing to the square root, which you can write now as C squared minus V0 squared, C squared minus V bar squared. Okay, now we'll plug in for V bar. Okay, something like that. Let's try and clean this up a little bit if we can. So pretty much we can do this, C squared minus V0 squared over C squared 1 plus V0 over C squared quantity squared minus V plus V0 squared over 1 plus V0 C squared quantity squared. Again, all of that to the square root. So if I factor out now, or basically bring this lowest denominator, if I take the reciprocal and then factor it out, I get 1 plus V0 over C squared times C squared minus V0 squared over C squared plus V, hold on. I have to multiply that out, that quadratic. So I get C squared plus 2V V0 plus V squared V0 squared over C squared. And I multiply out the other quadratic. I get minus V squared minus 2V V0 minus V0 squared. That whole thing to the square root. So I'm kind of running out of space. But I can cancel these terms, and that cleans it up a little bit. And what I get is a C minus V0 squared over, let's see, I would get a C so let's see, I would get a C minus V0 squared minus, let's see, yeah, C minus V0 squared, V0 squared over C squared, and then I would get a C minus V0 squared. Sorry, these are all squared, like so. And what you can see is I can then cancel out the, well, I can cancel that out, and I get a 1 plus v0 over c, 1 over 1 minus v squared over c squared, square root, which I can then write as gamma. Now this is the gamma of S measured with respect to S0 times 1 plus v0 over c squared. Gotta make sure I don't forget all my squareds. Like so. Okay. And so if I put that in, my electric field measured by S bar with respect to the rest frame is gamma 1 plus v0 over c squared times the electric field in the S frame. Okay. And if I now multiply that out, I get gamma, the electric field in the S frame, plus v0 over c squared, sigma over epsilon naught. Now if I look at that, a velocity times a charge density is the current, and so essentially what I get is gamma, the electric field measured in the S frame, minus v over c squared, bz over epsilon naught mu naught. And if you remember that epsilon naught mu naught is 1 over c squared, so in the end what I get for my electric field measured in the S bar frame with respect to the rest frame is gamma times the electric field of the S frame measured with respect to the rest frame minus v times the magnetic field measured in the S frame with respect to the rest frame. Okay, and so the last thing I can do is now look at the magnetic field. So the magnetic field measured in S bar is minus gamma 1 plus v0 v over c squared times mu 0 sigma v plus v0 over 1 plus v0 over c squared. So those factors cancel, and I'm left with minus gamma of a mu 0 sigma v plus mu 0 sigma v0, which means that I have minus gamma mu 0 v epsilon naught times the electric field minus bz, or minus gamma, or plus, I'll make it a plus, I'll bring it inside, I get a B field minus V over C squared times the electric field. Okay, and that's, I'll write it down just to clean it up. Okay, so now I've got the B field, and what you've noticed is that my B field measured in frame S bar is a mixture of electric and magnetic fields measured in frame S.